This is Euclid Book 10, proposition number 10, and there are some people who claim this is not a real Euclid proof, but we're going to go through it anyway. Here's the illustration. Okay, so what does this proof actually say? It says to find two straight lines incommensurable. Now, these two lines don't have anything that could divide them both, just like 8 and 9. The one in length only, and the other in square also, with an assigned straight line. Let A be the assigned straight line. Well, that's simple enough. Thus, it is required to find two straight lines incommensurable, the one in length only, the other in square also, with A. Let two numbers, B and C, be set out which have not to one another the ratio which a square number has to a square number, that is, which are not similar plane numbers. And let it be contrived that, as B is to C, so is the square on A to the square on D. So as B is to C, so as A squared is to D squared. Okay. For we have learnt how to do this. This is by Euclid Book 10, proposition number 6, porism. Therefore, the square on A is commensurable with the square on D. This is by Euclid Book 10, proposition number 6. So, we're not saying that A and D are commensurable, we're just saying their squares are. Mind that. And since B has not to C the ratio which a square number has to a square number, therefore neither has the square on A to the square on D the ratio which a square number has to a square number. Therefore A is incommensurable in length with D. And this is by Euclid Book 10, proposition number 10. This is by Euclid Book 10, proposition number 9, which is the last video we did. Let E be taken a mean proportional between A and D. So E is a mean proportional between these two. Therefore, as A is to D, so is the square on A is to the square on E. So now we say that as A is to D, so is the as A is to D, A squared is to E squared. That's what they're saying. But A is incommensurable in length with D. Okay, so in other words, there are no numbers that will measure both A and D. Therefore, the square on A is also incommensurable with the square on E. So there are no numbers that will measure A squared and E squared. And he's depending on Euclid Book 10, proposition number 11, which we have not yet proved. Which kind of causes people to say, wait a minute, is this a legitimate proof? Therefore, A is incommensurable in square with E. Therefore, two straight lines, D and E, have been found incommensurable, D in length only, and E in square, and of course in length also, with the assigned straight line A. Well, now you know that proof exists. Whether it's Euclid or not, we're not entirely sure. But, there you go. I will tell you more in a future video. Stay tuned.